All right, this last example kind of puts together everything we've done so far in this section. It says let v be the vector with coordinates with respect to b, given by 1, -2, 1. B is this basis, and then C is this other basis. Do the following things. First, find the normal coordinates of V. Okay, so we're given, these are the coefficients with respect to B. So for part 1, we're just going to do, let's see, it's going to be 1 times 335. I'm going to be lazy and not write my commas. Minus 2 times 155. Plus 1 times 555. I think we can do this in one step. That's going to be 3 plus 5 minus 2. Should be 6. Next up is going to be 3 minus 10. That's -7. Plus 5 is -2. And then we get 5 minus 10 is -5. Plus 5 is 0. So 6, -2, 0. That's the normal coordinates. Okay, now find the matrix that gives you, it converts from B to C. All right, so for 2, we're going to put, now it's B to C, so C is going to go first. C is going to be 2, 1, 3, 2, 3, 1, 3, 5, 3, then 3, 3, 5, 1, 5, 5, and then 5, 5, 5. Now I have not done this already, so I have no idea if this is going to give us something nice or if it's going to be hideous. But let's put it into octave and C. All right, so my matrix here is 2, 2, 3, 3, 1, 5, 1, 3, 5, 3, 5, 5, then 3, 1, 3, 5, 5, 5. Okay, that's not too bad. It's got some fourths in it. All right, so it's breaking it up, but we can handle that. The last 3 are 1, -3/4, 5/4, then -1, -19/4, 5/4, and then 1, 4, 0. All right, and I'm going to be lazy, and I'm just going to circle this part, or I guess it's a square or a rectangle. Anyway, I'm going to put that around there, and this is my matrix that maps P. It's called P, and it maps B back to C. Okay, then let's see. Part 3 says use this thing that we just found to find VC. Okay, so to find that, we're going to take that matrix. I'm going to label it below this as P that maps B to C. So we're going to multiply it by the coordinate vector with respect to B. And that's going to give us the coordinate vector with respect to C. So let's see, what is the coordinate vector with respect to B that was given to us up here? 1, -2, 1. All right, let's use octave to do this. Interesting thing with octave, I'm going to take this matrix RREFM, I'm going to call that P. Now the problem is P is a, let's see, it's 3 rows by 6 columns. So let's see, 3 rows by 6 columns. There are ways you can use Octave to extract parts of a matrix. I want to say if I put the parentheses here and I put a colon for this because I want all the rows, and then I want columns 4, 5, and 6. And that gives me exactly what I want. For computer science people, it might drive you crazy, but the indexing here starts with 1. So let's see, that's exactly what we want there. So I'm going to take that. I'm going to give it a name, P, B to C. Okay, so that's my matrix. I'm going to multiply that by the column vector, 1, -2, 1. Of course, you know, all that fiddling around with stuff, it might have been quicker just to retype it in. But anyway, this will give us 15 over 4, 39 over 4, -7. So that's my answer for 3. And then let's see, what does 4 say? It says find VC directly using the answer to part 1. Okay, if we want to find VC directly, what we're saying is we're trying to find the coordinates of V with respect to C, and we know that the actual coordinates are 6, -2, 0. So here's C. So we're setting this up 2, 1, 3, 2, 3, 1, 3, 5, 3. We're saying what do we have to multiply those by to get, what was it, 6, -2, 0. All right, so if we do this, oh, I'm sorry, I didn't realize I had Octave still on the screen. So we're setting this up and we're solving it, and this is going to give us the coordinates with respect to C. This is called V, not X. Did we already find that? Yeah, we found that in part 3, but this, we're computing it a different way here, and it should give us the same answer. So let's see. All right, is there any cheap way to enter this in? I'm going to go back up until I get to, let's see, that was my M. Is that from this problem? Yeah, that's from this problem. So M was that. Okay, so that's the first part of this matrix. What this is, by the way, the colon here, we're basically giving a range. This is the range that we want for the rows, and this is the range we want for the columns. And if you just put in a colon with nothing around, it takes the whole matrix. So I could take this, and then I'm going to tack on the column matrix 6, 2, 0. It gives me what I want. Of course, you could just type the whole thing in, but anyway. REF MM, that gives me this. Gives me 15 over 4, 39 over 4, and then -7. So if we did everything correctly, that should be the same answer we got for the previous problem. Only we did it slightly differently, and that's pretty much it. So anyway, that's it for this section.